Alright, so let's look at Lagrange multipliers. And so the question we have is if we have a function in x and y, that is 2x minus y squared, and it's going to be constrained by the ellipse x squared plus 3y squared equals 36. We want to find the extrema. So what we're going to do is we're going to use Lagrange multipliers, or the differential equation that the gradient of f times the gradient of g should be equal. Also, at the same time that the constraint is applied, and for this to work, we'll make this constraint our function. And we'll set it equal to 0. So that will make our constraint into a function of xy, and we'll hold the constraint conditions equal to 0. So delta f, or I'm sorry, the gradient of f is 2, and for the y component, equals negative 2y. So the gradient of f is 2I hat minus 2y j hat. And for our gradient of g, we get 2x, g, and negative 6y. And so our gradient of g is 2xi hat minus 6y j hat. Or not minus, plus, because that's a 6 here. Sorry, that's a plus. The minus is there. This is the gradient of g. So if I set these equal, then the y components have to equal the y components with this Lagrange multiplier. So 2 is equal to 2 lambda x, and negative 2y is equal to 6 lambda y. And a couple things to note. We'll notice that y divides out, so we're going to have to ask ourselves what happens when y equals 0. Because when we divide through by y, we lose all relevance of the y equals 0 solutions. Over here, what we'll find is if we solve for lambda equals 1 over x, or x equals 1 over lambda. They're reciprocals this way. And if I come over here, then I can give myself, let's see what I can do here. If I put this, if I put x into here, negative 2y equals 6 over xy. And so if I solve this for x, I'll multiply x to this side, and I'll get negative 3. And so these are my possibilities here for x as being negative 3. And if I go back to my constraint, then if x is negative 3, I have 9 plus 3y squared equals 36, or 3y squared equals 27, or y squared equals 3. So y is plus or minus 3. On here. And then the other constraint I'll look for is when y equals 0. So when y equals 0, then x squared equals 36, and x equals plus or minus 6. And so plus or minus 6, comma 0. And so we have 4 possible solutions: negative 3, positive 3, negative 3, negative 3, positive 6 and 0, and negative 6 and 0. Now, so we look at them in context of our original equations, anywhere the sign of y changes won't be affected. So if we put negative 3 into our initial equation, we're going to get negative 6 minus 9 or negative 15. So at negative 3, comma 3, and negative 3, negative 3, the function f of xy is equal to negative 15. Now if I put in 6, the negative 6 gives me negative 12, but the positive 6 gives me positive 12. So this lies between negative 15 and positive 12. So this is neither a minimum or a maximum. So if we put in at 6 comma 0, then f of xy is equal to 12. And so we have this is maximized at 6 comma 0 given the constraint, and minimized at negative 3 comma plus or minus 3. And that's the Lagrange multipliers working out for us.